Alright, so this is picking up where the last video left off. They left us on a cliffhanger where we're about to learn about methods. So let's get it. Structs and methods. Method syntax. Methods are similar to functions. They're declared with the fn keyword and their name. They can have parameters and a return value, and they contain some code that is run when they're called from somewhere else. However, methods are different from functions in that they're defined within the context of a struct, or an enum, or a trait object, which we will cover in chapter 6 and 17 respectively. And their first parameter is always self, which represents the instance of the struct the method is being called on. So here we go, example of defining a method. We already have our struct, rectangle. Oh, implementation, IMPL. Let's change the area function that has a rectangle instance as a parameter and instead make a area method defined on the rectangle struct. So it looks like they changed this and they moved it up here. I can just rewrite this from the beginning. So let's go up here and it looks like the implementation is IMPL. Keyword, rectangle, they know it, comes down here, and then within this code block is where the methods go. Fn, area, takes in one parameter, which is going to be the first parameter, which is self, and it's going to return u32, just like it did before. And in here is where we do all the magic. Self.width times self.height. Alrighty then. And then here we can just say rect1 dot area. Okay, that works. That works. Well, let's prove it works. And the area is still right here. To define the function within the context of rectangle, we start with a implementation block. IMPL, implementation. I was just joking with the sounds. Then we move the area function within the implementation curly bracket and change the first, and in this case, only parameter to be self in the signature and everywhere within the body. In main, where we call the area function and passed rect1 as an argument, we can instead use method syntax to call area method on our rectangle instance. The method syntax goes after an instance. We add a dot followed by the method name, parentheses, and any argument, which is right here. In the signature for area, we use ampersand self instead of rectangle, ampersand rectangle, because Rust knows the type of self is rectangle due to the methods being inside the implementation rectangle's context. Note that we still need to use the ampersand before self, just as we did in ampersand rectangle. Methods can take ownership of self, borrow self immutably, as we've done here, or borrow self mutably, just as they can any other parameter. So that's pretty cool. So what they're saying here is that we can write self here because Rust knows this self is equal to rectangle, mainly because it's in the implementation block of rectangle. We use the ampersand here because we want to borrow self. However, if we wanted to, we could also take ownership of self, and if self is mutable, we can change it. We've chosen ampersand self here for the same reason we use ampersand rectangle in the function version. We don't want to take ownership, and we just want to read the data in the struct, not write to it. If we wanted to change the instance that we've called the method on as part of what the method does, we'd use mutable self or ampersand mute self as the first parameter. Okay, so if we wanted to change what this equal to, we use this. Got it. Having a method that takes ownership of the instance by using just self as the first parameter is rare. This technique is usually used when the method transforms self into something else and you want to prevent the caller from using the original instance after the transformation. I have, off the top of my head, I can't think of a reason why you would want to do that. It exists because they mention it, but that does sound rare. The main benefit of using methods instead of functions, in addition to using method syntax and not having to repeat the type of self in every method signature, is for organization. We've put all the things we can do with an instance of a type in one implementation block rather than making future users of our code search for capabilities of Rectangle in various places in the library we've provided. Alright, so they're saying the main benefit is that all of the things that Rectangle can do is now put in this nice small block. People don't have to go searching for it. That's where it's expected to be. And then they're giving us backstory on this operator. So where's the arrow operator? In C and C++, two different operators are used for calling methods. You use dot if you're calling a method on an object directly, and arrow if you are calling the method on a pointer to the object and need to dereference the pointer first. In other words, if object is a pointer, use the arrow. It's similar to object. Well, here you can just read it. I don't know how to say that verbally. Rust doesn't have an equivalent to this arrow operator. Instead, Rust has a feature called automatic referencing and dereferencing. Calling methods is one of the few places in Rust that has this behavior. So what they're saying is, yes, this is a thing. Yes, we should care about it at some point in time, but Rust does this for us automatically, so not really. Not really. Here's how it works. When you call a method with object.something, Rust automatically adds in ampersand, ampersand mutable, or star, so object matches the signature of the method. In other words, the following are the same. p1.distance ampersand p2 is the same as, you have your parentheses, you have your ampersand p1, so I guess dereferencing it, dot distance ampersand p2. The first one looks much cleaner. This automatic referencing behavior works because methods have a clear receiver. The type of self given the receiver and name of the method, Rust can figure out definitively whether the method is reading ampersand self, mutating ampersand mute self, or consuming self. The fact that Rust makes borrowing implicit for method receivers is a big part of making ownership ergonomic in practice. Yeah, makes sense. Thank you for doing that for us. So, methods with more parameters. Let's practice using methods by implementing a second method on Rectangle Struct. This time, we want an instance of Rectangle to take another instance of Rectangle and return true if the second Rectangle can fit completely within self. Otherwise, it should return false. That is, we want to be able to write the program shown in 5-14 once we've defined the canHold method. So what they seemingly want us to do is write a method that allows us to check to see whether a second rectangle can fit within our first rectangle. Alright, and what do they have here? They have different instances of rectangle. So let's write some of those here. Let rect2 equal rectangle. We will give you a width. They give you 10 and a height 40. Let's rect3 equal rectangle width of 60 and a height of 45. And we haven't written the method yet, but they have the print lines here, so I can just do the print lines. Print line can rect1 hold rect2. And this is what our method should look like. Our method call rect1 dot can underscore hold, and we pass in a reference to rect2. And then we have something similar for the next one. Can rect1 hold rect3. Rect1 dot can hold reference to rect3. And do they want us to write can't hold ourselves, or do they have it here? They do have it here. But we should probably read through this. So all we wrote here is can rect1 hold rect2. And we have rect1, we call the method can hold, which we haven't written yet, and we pass in rect2. And we do the same thing for can rect1 hold rect3. And now that we have that written, let's just go down to writing the method. So we're here in the implementation block, we write another method called can hold. And the first parameter is self, or first argument. And then other is going to be a reference to rectangle. And this is going to return a Boolean. And now we do self width is if the width of my instance is greater than this other instance, other dot width, and self dot height is greater than this other's height, then yeah, that's true. We can hold you. So let's print this out and see what it says. Can rect1 hold rect2? It says true. Let's look at these dimensions. So rect1 is 30, height of 50. Rect2 is width of 10, height of 40. Based on what we have here, rect1 is width is greater than rect2's, and rect1's height is greater than rect2. So yes, it can hold it. We got true. And then for can rect1 hold rect3, we got false. Rect3 is just huge. Width of 60, height of 45. 45 is less than 50, however 60 is greater than 30. So, I mean, rect3 is too big to hold. Associated functions. All right. Another useful feature of implementation blocks is that we're allowed to define functions within implementation blocks that don't take self as a parameter. These are called associated functions because they are associated with the struct. They're still functions, not methods, because they don't have an instance of the struct to work with. You've already used the string ... or colon from associated function. Associated functions are often used for constructors that will return a new instance of a struct, or of the struct. For example, we could provide an associated function that would have one dimension parameter and use that as both width and height, thus making it easier to create a square, rectangle, rather than having to specify the same value twice. And here's an example. Let's make a square using an associated function. Square, first parameter is going to be size, u32, and it's going to return a rectangle. And we're just doing rectangle. Should be width and height, right? Width equals size, and height equals size. And that should give us a square. Oh, and then when we call this, to call this associated function, we use the colon syntax with the struct name. So we can say, let's do it right here. Let square equal rectangle colon, and does it pop up? It does. Square 3. And because it's a rectangle and rectangle has the debug, we can just print that out. Print square is SQ. Ooh, SQ. See that down here real quick? Could not compile. What did we do wrong? Let's see what it says. Does not have a display format. Wait, what? Did not have it? Oh, that's what I forgot to do. It's the debug format. And then if I wanted to have it read down, hashtag. That I have to remember. Square is rectangle with 3, height 3. Okay. Next thing we're going to move on to is multiple implementation blocks. Each struct is allowed to have multiple implementation blocks. For example, in listing 5-15 here is equivalent to the code shown in 5-16. Alright, so what they're saying is we can have multiple implementation blocks and we can separate them. That's fine. This is the same as what we have. There's no reason to separate these methods into multiple implementation blocks here, but this is valid syntax. We'll see a case in which multiple implementation blocks are useful in chapter 10, where we discuss generic types and traits. Okay, so summary, we have came down to the end. Structs let you create custom types that are meaningful for your domain. By using structs, you can keep associated pieces of data connected to each other and name each piece to make your code clear. Methods let you specify the behavior that instances of your struct have, and associated functions let you namespace functionality that is particular to your struct without having an instance available. But structs aren't the only way you can create custom types. Let's turn to Rust's enums feature to add another tool to your toolbox. Alright, enums seemingly are next, but in terms of structs, we are done. I hope you enjoyed that. Hope it was useful. Peace.